Good evening, and thanks for joining tonight's TI Technology webinar hosted by Texas Instruments, where tonight we're going to take a look in your math classroom and see where maybe coding and STEM fit into that classroom. My name is Mike Houston, and I'm the moderator for this event. I teach algebra and calculus near Pittsburgh, where I use TI technology to make tough-to-teach, tough-to-learn concepts accessible to all my students. Tonight we're really lucky to be joined by our two panelists, Ellen Brown and Brad Poznansky. Ellen is a Texas Instruments national instructor and lives at the Pomfret School in Pomfret, Connecticut. After teaching music for 25 years, she switched over to teaching math in 2003, and then she added engineering in 2014. She has always been captivated by the possibilities of TI technology in both subjects. Ellen enjoys students, teaching, conducting TI workshops, and is passionate about helping students and educators attain their goals. Ellen loves being a mom of three, a wife to an awesome calculus teacher, cooking, gardening, and being creative. Ellen, thanks so much for joining us tonight.
I'm looking forward to it.
And Brad is in his 23rd year of teaching at Comstock High School. He has been using TI technology in his classroom ever since he student taught. He's a firm believer that you never stop learning, and that is evident in his pursuit of new and innovative challenges made possible through TI technology. Brad has presented at local, state, national, and international conferences. He coaches 3 varsity sports and loves to sail in the Caribbean. Who doesn't love that? Brad, thanks so much for joining us tonight.
Happy to be here, Mike.
We're expecting a large crowd, so your audio is muted. Feel free at any time to say any questions to Brad or Ellen using the Q&A window on the right side of your screen. We'll also be using the chat window to send general messages. As a reminder, the session is being recorded, and we'll provide a link to the event certificate of attendance as well as a link for the documents at the conclusion of the webinar. We hope you don't have any audio issues, but in the event that you do, try selecting Communicate from the WebEx menu and choose Audio Broadcast. At this point, Brad is going to discuss our agenda.
We just went over the welcome and introductions. So the way the logistics are going to work for the webinar is that we're going to go over several different topics. First, how to get started, some STEM activities, and finishing up with some engineering design processes. And in between each, we're going to try to allow some time for questions to be asked about that particular topic or any topics that might arise that you have some questions with.
Thanks so much, Brad. And Ella's going to discuss our expected outcomes.
So the expected outcomes for tonight, we're going to highlight coding and STEM projects in the math classroom, specifically using the TI-Innovator Rover, TI-Innovator Hub with the TI LaunchPad on board, discussing our challenges and lessons learned because nothing ever goes perfectly, and share some of the implementation strategy that we've tried and learned from and moved forward from and just had a blast with.
Thanks, Ellen. Brad, you have control. Feel free to share your screen.
All right. So I believe we're in here. Let's try it. Okay, so we're discussing about coding and STEM in the math classroom. Ellen and I are two different levels of coding and STEM in the classroom. I'm more of a novice compared to Ellen, who's been doing this for quite a while, but so we're coming at it from two different aspects. I feel that teachers might be apprehensive to jumping into STEM projects and getting into coding. And, part of the reason why hopefully you're here is to see how you can include it into your math curriculum and the reasons why we want to teach math and STEM in the math classroom.
So one of the things we came up with this title, The Adventures in Coding and STEM in the Math Classroom. We're just two teachers that try out stuff in our classroom. And teaching students to be problem solvers will benefit the whole curriculum. And that's what Brad and I have been as we've tried this in our math classrooms as problem solvers ourselves. So we feel that modeling it for our students is just so incredibly important. And another thing about coding and STEM projects is attending to precision. And when do you not need that in math? So I have found my kids to be better at noticing things, noticing patterns, and noticing details.
Yeah, some of my students, when some of the code goes wrong, become actually better proofreaders, and they're able to better pick out things that go wrong. Some of the crossovers, I've been an Algebra 1 teacher for a long time, is that I discovered within the coding is with the functions of inputs and outputs. What are you going to input into the calculator? What are you going to opt for as an output or display? So again, get some thinking about those types of terms. Might not be specific to an f of x function problem, but there it's part of it. And then one of the other things that's really kind of interesting and neat to see within your students is the creativity that comes out of them with some of these different projects and the ideas that they come up with.
Yeah, in the creativity piece, it allows a student to that maybe is not good at pencil and paper f of x equals, but can be very creative in a different way and shine in the math classroom, giving him or her confidence to try some other problems. So there's also multiple entry points. Speaking of Algebra 1, and I teach Algebra 2 as well, and there's so many entry points with the coding, starting with a handheld, then going to the Innovator, and then adding kits or Rover. There's an infinite number of projects and infinite number of starting points, not only for the students, but for the teachers as well. You can start by turning the calculator on and writing a small program of just a couple of lines.
And the other thing that we've seen is just the student excitement. When they program something and a light comes on or a buzzer sounds or some music starts, and the excitement that they did that. They had started with something or starting with nothing and then created something. So then very quickly after that, you get the questions of what if or how can I, which is a real turn on as far as getting them involved and part of that creative process. So I guess some of the things as far as Ellen was saying about jumping in and starting from scratch is don't be afraid to make mistakes. I started with a couple little pieces of code and things didn't go right and we took it from there. So also find someone maybe in your department or someone to try it out with. It doesn't have to be a whole entire school-wide thing, and that way you'll find it a little bit more enjoyable.
I have an awesome co-teacher that we teach between us. We teach 4 Math 3. We have integrated math in our school, Math 3 classes, and she is a third-year teacher, but she's happy to jump in with any project, which is really cool because then we have 4 classes to try it out on instead of just a couple. And also, it's so great to bounce ideas off of her and her off of me, of course, and just doing it together is really just amazing.
All right, so we're going to move on to our first point of interest is the 10 minutes of code that's on the Texas Instruments website. So if you're looking for a point of entry with little, if any, coding experience, this would be the place to do it. If you have TI-84, TI-Nspire calculators in your classroom, they have some very pre-made, self-paced codes that you could follow and lesson plans with handouts for the students. One thing I'd like to point out, I'm not sure if you guys can see my pointer or my mouse, but within these slides, which you guys should get at the end of the presentation, if you click on the 10 minutes of code at the top, it will link you to all these different projects that we have. So this one bounces you out to the Texas Instruments website. If you click on the activities and TI codes, get it there. It'll take you to that page. And again, you can start with just the 84 or the Nspire handheld. You can build up, and it's a nice progression of learning the different pieces of the codes, different functions that are available within the TI coding platform. Then you can move up to the 10-minute of codes with the Innovator Hub, which we're going to show you, also with the Rover as well.
And so one of the things you should be really, comes to the things that can go wrong. Make sure that all your calculators are updated and that whole class is on the same operating system, or you're going to get a lot of issues with kids looking at different screens. My screen doesn't match what it says. So make sure the calculator is updated. And also on these 10 minutes of code lessons, there's at least 2 different ways to approach it. You can do handouts for the kids and print them, or if they go to the website themselves, they can simply click from screen to screen and have step-by-step instructions that way. So either one works really well. I've tried both.
Yeah, and as far as once they follow the code and they see what they can can do with it, that's when they start to, trying to do their own ideas and how they can create different pieces. I've actually incorporated in some of my classes where if they could code a certain program that would help them, let's say, find the slope of a line containing 2 points, I sometimes give it as a little bit of a bonus that they could use it on an exam. So it depends upon how creative you want to go with it. Obviously, it's up to the individual teacher. But from there, the possibilities are endless with it. And I'm still learning, and starting out with basic inputs and outputs and get to for loops and while loops, and you can keep on going from there.
So one of the things I did in my classes is I had just started this last fall when the Rovers were new, and the students were just getting into them and just starting their very first lessons of code right before we had our family weekend. And so the students wanted to show their parents what they'd been learning, and one student stood up and he was talking about what they'd been learning, and he says, and we've been learning to code. And the reason we've been learning to code is because it teaches us about inputs and outputs and functions. Well, I just about fell out of my chair because I was just, wow, they really do listen and they understand why we're learning what we're learning. So that was a really cool moment.
So after, using the 10 minutes of code and getting the students used to coding on their calculators and the idea of coding, one of the first projects that could take you to is the mood ring project. And this involves the Innovator Hub, which you can see this little box that will attach to the calculator. Has various functionalities with inputs and outputs. Also a LED screen. It does do audio and sound. So there's, as Ellen said, an infinite number of possibilities. So in this particular activity, the students would build a ring that will temperature. It's got a temperature sensor. It'll display the temperature on the calculator screen and will assign a different LED color for that particular mood or the temperature that they came up with. So, a couple, key points here is, we're talking about inputs and outputs, inequalities, because they have to come up with a temperature range that would display a certain color. The students get the choice of what color they would like to associate with which mood. So the 256 colors that are available, this is a great little way for them to experiment with the color. And we've found that there's different entry points into this activity where you can have it very scripted for the students, where you can give them a piece of the code and have them alter it, so that way they're doing a little tweaking and a little adjusting to it. It's not a long project, so it can be done in one class block or 2 class blocks, depending upon how proficient you are and the students are with them. And you can, as you see in this slide here, I had 2 students working together in teams. And part of the reason for this was I don't have 20 of these little innovator hubs in my classroom. So it was a good opportunity to team these 2 students up.
So the other part of this is that the students get to phrase what the calculator will display on the screen. So not only displays a color, but it can say, I am happy, or I am cold, or it's too hot. And so it's a color and a saying. So they learn how to code display. You can see them working in teams there. And one of the things we encourage in our classrooms is teamwork, not parallel group work. So they really have to work as a team, as you see these 2 students here doing.
Yeah, and I had a couple different levels of students using this. So this was an accelerated class, so I had them do a lot of building of the code themselves with a basic structure. So that was a little bit of a challenge for them to start playing around with, how warm does the temperature get? How cold does the temperature get? How refined do you have to be with your intervals as far as different moods was concerned? Now, if this was just one of my regular classes, I might have given them all the structure and then just had them do some slight adjustments with them.
So that's what I did. Since I did it in a regular level classroom, they had to figure 3 different temperature ranges that they could attain. So they were putting it on their finger or putting it near the window. And so they had to figure out 3 different temperature ranges and then just tweak them because it was a regular level class. They were feeling a little apprehensive about the coding, and it was a great intro activity to get them to do it. And then once you look on their faces and see, oh, wow, I did it. My calculator's doing what I told it to do, those inputs and outputs again.
And just, again, when the kids, how can I or what if statements that they come up with is they knew that they could make a sound with this. So not only did they want to have a light display and the text on the screen, but they also wanted to try to associate different sounds with different moods. So again, there was that creativity of, well, let's keep going. And that wasn't even a part of the code or the pre-coded lesson that you could have given them. So
are there questions on this activity? It said if I have a class of 25 students, how many hubs should I have per class? It works pretty well with 2 or 3. So when you start getting 4, if you have to do 4, it will work. More than that, I wouldn't do. And 3, I'd say would be an optimum number. I've done both 2 and 3.
Yeah, I would agree. I would agree with, ideally, 2 would be great, but, again, 3 it will work.
Reasonable.
Yes.
And then all you need is Chanel stems, as we call those fuzzy things you wrap around your finger.
And they like being able to pick out their color for their rings. Yeah,
student choice. Anytime you can give a student a choice is just great.
Any other questions?
We had a question from Jenny. Okay. She wanted to know, where do you get the sensor for the mood ring project? I think you mentioned that, though. No, I'm sorry, the sensor. I don't think you mentioned that.
No, we didn't mention that. So TI has been slowly putting those sensors. It's not one of the ones in the kit that you buy, but you can get it on different various vendors, and we could probably give a link for that afterwards, Mike.
We can put it in with the notes.
Yep. Is there a guidebook? There is. If you click on the link itself, Brad, can you go back to that slide and click on the link so they can see that there's a mood ring activity right on the other way.
There we go. Right.
There we go. And if you click on that link, it takes you right to all the supporting documents. You have a handout for the students. You have the 84 project materials, and you have the Nspire project materials, which comes with the TNS file or the CE file, and you can just go from there with some suggestions on how to implement this in your class. That was a question from Osama.
We're going to move on to the Rover.
Yep, on to the Rovers.
Okay, so I guess, we as instructors have had exposure to the Rovers, but if someone's, tuning in for the first time tonight and hear us talking about Rovers, they might not have any clue of what we're talking about. So, the Rover is there's a Rover. It's programmed by having a handheld on this cart and, almost like a robot. And the Innovator hub that you saw in that last project, that's actually inside this Rover. So it's all hooked up, and you'd be programming this Rover to do various, acts and tasks.
So that student on the top left corner, he is putting together a Rover right out of the box. So I had my students hook them up so they understood what was going on the inside, and not completely how they work, of course, because that would be taking it all apart. But I actually had my students hook them up.
So one of the things that this Rover can do, just give you a couple ideas, but before we go into some of the other stuff, is it can move forward a certain amount of distance. It could turn right. It could turn left. We could tell it how many degrees to turn right, how many degrees to turn left. And one of the neat things, if you see up here in the upper right-hand corner, a student has a marker in their hand. You can insert a marker into this and have it draw different shapes. So as far as, activities that you could come up with, there's an endless number of things that you could have them do. And, immediately my mind jumps to geometry class and sketching objects and sketching figures with this. So, but that was one of the, first things that came to mind is you're going to, instantly program this thing to move forward, move right, move left. And all of a sudden, the kids get really turned on with it.
And it has a sensor in the front, so it'll sense how far it is from something, and it also has a light on the bottom that will follow a line or follow a color. And since it's the Innovator, which is running the Rover, it also will play music and dance and so forth. It also parks better than some adults I know. So they have a parallel parking there on the left, and 2 Rovers leave the station is way more fun than 2 trains leave the station. That's my freshman class doing 2 Rovers leave the station, trying to figure out when they're going to meet. And they had a lot of fun crashing into each other.
Yep. And, even within the projects, when you had them drawing it, you could keep, talk about, low floor, high ceiling activity. Have the students have to draw a square. And then from that point, they might put 4, 5, or 8 lines of code in there. And then you start challenging them with what they've learned about coding is, could we do this in 2 lines of code? And, really try to, up that level of, which would involve some for loops, but again, getting them to think, how could I do this in less steps? How could I be more efficient with this? So you're dealing with a lot of, thinking that's going to be going on with them. And, you'll never know which students are going to be the ones that excel with this. It might not be those students that are the great test takers. It's, the ones that are really good thinkers and, the ones that are willing to experiment with these activities.
This freshman class that you see on the right there, that class was teamed up in pairs, and the 2 probably the kids with the 2 best grades in the class didn't even finish the activity, where the 2 that were, sort of mediocre, finished the whole thing and wanted more. So it was very cool to see.
And here are just some examples of some of the codes that they had come up with.
So that's using the Navigator system, and in case anybody's not familiar with it, you can see all the handheld screens up at once and follow along, and this way you can really pinpoint who's having difficulties or is checked out or hopefully checked in and coding. And once again, they work in teams. So this activity, they're going from 2xy, which is one of the commands the Rover does, and then to another xy, and the students have calculated the distance between the 2 ahead of time, and then they code it on their Rover, and the Rover will also calculate it for them if they've coded it correctly, and they compare the 2 results. So they had a lot of fun with this, and it was a great way for them to be driving around on the coordinate plane. So this student, as you see on the left there, the Rovers were brand new, and she wanted to try it. And so she wanted to code a square, and she came and said, "Can you bring a Rover to the library during my free block?" So we did, and she came over, and she put her calculator down on it, and this was the result. You can see how intently she's watching that Rover to see if it works, and if you watch her reaction at the end, it's quite something. She's just a happy camper. There's that expression. I did it.
So we have questions for you.
Questions about the Rover? They're pretty durable. Okay, so we got a bunch of questions here. They're pretty durable. I haven't driven off a table yet, but they've been handled by lots of kids.
I recommend
a project like this, anywhere between 30 minutes. I had those freshmen that you saw were up and running within 30 minutes and got something done, to as long as you like, because it depends on how long the projects are.
As far as the being on top of a table, whenever I had them in my classroom, it was automatically they had to be on the floor before they hooked up the calculator to it, just because they could have a tendency to program it to go a little bit too far.
And the rover will drive around in circles, so we have a quadratic curve. So it does drive in, technically it does drive in curves because the wheels can go at different rates. So it depends on how mathematical you want to get. I hope that answers that question. I'm not sure. If it doesn't answer the question, then you can ask again.
And as far as, the progression, as we said, we started with the 10 minutes of code. That's just having the handheld, which we assume, most classrooms already have the handhelds. The next one would be to work your way up to the hub and then adding on some of the sensors that come with it, or not come with it, but some of the kits that you can get along with it. And then, the next level would be the Rover, because you already have the Innovator Hub, you already have the handheld, and then this would be one of the next pieces to add to your toolkit.
So there's a question, can we add a light sensor? And then another similar question, are these devices able to accept sensors similar to Lego Robot? So I saw a demonstration where somebody attached two sensors to the sides, and then as it drove around on a table, it sensed the sides of the table and backed off and drove in a different direction. So I've never tried to attach a light sensor to it. I mean, there are some outputs, places for outputs and inputs on the Rover. So can you attach an arm that picks up things? I do not know the answer to that question.
See, these questions are great because
yeah,
these folks who are asking these questions we're gonna tune into one of their blog pages and see their attached arm.
Right. So So yes, you can put any of these projects can be done both on the Nspire and the CE, the 84 CE. So this person, so the CE definitely. Oh yeah, Michael already answered that question. So all of these projects work on both. We have them demonstrated with the Nspire, but they all work on both.
And that one question about the arm, I did see someone hook up the servo that they were able to have a pen raise and lower.
Oh, that was cool. Yeah.
As attached to it. So I'm assuming that if you can get a pen to raise and lower, if you have the engineering wherewithal to make an arm, that you probably could do that as well. Just haven't seen it yet.
All right. So remember, if you think of another question, we can always check it at the end too.
Hey, Ellen, we actually got one more question from Justin. And just want to know, does it have any way to record any data and export it to a table, such as rates or distance or time?
That's a good question. We'll have to get back to that one. Brad, do you know?
I do not know.
I haven't tried it, so I don't. I know you can import data out of the Innovator and import it to a table, but we'll get back to you on that one.
Just thinking off the top of my head, I think with the temperature probe, I've had it where it did populate it into as it's doing the reading of the probe.
Right.
Had it populate into a table, so I assume that you can do that.
Right. We're assuming you can because that would make sense because the Innovator does.
Sure.
All right, onwards. The pet car alarm. So in this day and age, we have, unfortunately, news stories every week, just about, seems like, with pets and, unfortunately, children getting left in the car. So this is my driveway, and I put the pet car alarm out there with a soda bottle over it, heated right up. And if you look closely, you can see the lights are flashing, the window rolls down, and there it goes. And the calculator displays it's too hot and Logan's in the car. Logan's a dog that comes to class every day, so the students feel that this is very real because he's right there, and they want to save him. So it's quite a cool project. So this project, I had the kids code it. The students coded it themselves. I did not give them the code. And this was a multiple day project. We did it over 2 weeks, partial classes every day or every time we met. So not the whole class for 2 weeks. And trying to teach them the code and the steps, I came up with the major steps, and they had this outline of what would happen. And then of course, multiple steps of a yes, no question. So is is the inside of the car okay for the dog? Yes, no, then what happens for each of those? And then they got colored cards with the sub steps for each of the main steps, and they had to put them in order to organize their thinking, and once again, working in teams. So each of the orange ones were, each the main categories were a different color, and that really helped them. That's what they said anyway. And they were able to write the code, so that was a good way to do it. I would definitely do it this way again. So there they are wiring up the car. So this also has multiple entry points. You can pre-wire the car yourself or get a couple of students to help you and just focus on the code. You can do the whole thing and have them wire the car up. One of the things we ran into is we did it with multiple classes and we only had 6 cars. So each class had to unwire their cars so that the other class could wire up, or we were debating having teams across classes. So each team of 3 or whatever in each class was teamed up with another team of 3 in the other classes. But that didn't work out very well. So if anybody tries that and it worked out well, let me know how you did it. So they unwired the car every time. So there it is, wired up and ready to go. And you can see in the background the computer has the slides on it that I was giving them for the project with some of those steps and what we were trying to achieve for each of the class periods that we worked on this project. And they all had success, and they got to color their cars, which was fun too. And they all had success. I wasn't sure they would, and they did. They really surprised me with how well they persevered and did this project. So I think in the next slide, yeah. So I purchased an inexpensive heat gun to simulate the sun because it was quicker than putting your finger on it and heating it up every time that way, so they could do more tests. And we started to head them toward the engineering design process too by testing and then tweaking and then testing and figuring out what they wanted to do with these sensors.
I think that's the next slide, right? There
Yeah. Yeah, so that's on the next slide. So are there any questions on the pet car alarm? That's quite a bit bigger project than the other ones we've talked about so far, because it has multiple sensors. So the students need to understand what happens in what order, which once again is attention to detail, attention to precision, inputs and outputs, and all this cool math stuff. And they had to understand what a temperature range would be dangerous. They had to do some research on what was kind of out there, what should happen, what would alert passersby to the fact that the dog or the child was in distress.
While we're waiting for questions, I just wanted to emphasize that, the whole engineering design process, just, to reiterate what Ellen was talking about is, it doesn't end. They keep going, and the whole refinement and improvement and asking questions. And, you just look at the different pieces of it, just getting the students used to that. They're, used to kind of linear thinking of, here's where I start, here's where I end. And that's where it ends as far as a math problem is concerned, where here it's, hey, how can we improve on this? So again, getting them to think differently.
Right, and when they do think like that too, we try to tell them not to make their prototype so perfect that they don't want to touch it. Like they have the light in a certain place on the car. It's not really working, but they spent a long time trying to put it there. So getting them to understand that you got to move it because it's not working there. I know you spent a lot of time, but it's got to get moved. So not getting married to that first idea or the fact that they've spent so much time on one thing. So any questions on this project? Okay, well, we can always come back to questions. There doesn't seem to be questions on this one.
Okay, so the next one was an automatic dispenser. This is a real fun project because it can take many, many forms. If you think about, nowadays, there's so many different machines that dispense things automatically. And we came up with some ideas of different types of things that you can dispense, but then the kids could come up with others. So here the shift, really, the focus shifts really from coding to engineering and design. So within this project, we gave them the code that they could alter slightly, but yet within that, it was more about the design of the project, and gives the students some freedom in deciding what they want to create. So this is the code that we gave to the students there wasn't much that they really had to change here. Could have been slight tweaks within the program that they do, but it was the students would have a light meter where once they place their hand over it, it triggers the servo that would start not dispensing, but triggering some other apparatus within the dispenser to dispense whatever the item is that they want to have dispensed. So
when we did this in our classes, well, go back to that other screen. I gave them this code and this paper so that they knew if they needed to change, for instance, the motor, in their design, the motor needed to go counterclockwise instead of clockwise. They knew which number to change, and also the speed of the motor and the timing of the motor. So many of them would ask me, how do I make the motor, for instance, go around just once? And I said, well, what can you control? Well, the direction, speed, and the time. I said, so clearly you can't tell the motor go around once. So which of those is going to get you to do that? So getting them to think in that way and understanding that they can change this code. And so it's interesting that we're doing this webinar tonight because I've spent the last pretty much 24 hours on this project because my engineering students had this as their term exam finishing today. So they had a 2-hour exam block and about an hour or two of homework to do this project. And they did a great job, but watching their sense of accomplishment was just marvelous. So I was really glad to be able to talk about this tonight.
So one of the things that is interesting about this is you put a bunch of supplies out in front of them. And I think Ellen, when she presented this at one conference, showed the movie clip from, I think it was Apollo 13, where they get the astronauts back from space and they just dumped a box of things out on a table and said, figure it out. So here's, an example at a workshop, all the supplies. We didn't tell them what they could dispense, but as you see on the slide, it could be candy, toilet paper, ping pong balls, business cards. We've seen them, all those be dispensed by some sort of device. And so once they get a chance to look at what they have to work with, they start brainstorming to think about what they could come up with for an idea. And one of the really important pieces with this engineering design process is coming up with their sketch.
Right. So sketching or concept sketching is a really important part of the engineering design process because kids want to just start building. And if you can get them to draw first, I know there's adults in this left-hand picture, but it was such a good picture of the sketching. I did this with, this is some of my faculty members, and I did this activity with them instead of faculty meetings at the beginning of the year. And by the way, they had a blast. And so one of them came up with this right-hand side with this toilet paper dispenser. And the concept sketching, when you have a chance, you can click on that link and it shows you how to set it up and how to do it. And I've done it with adults and with students, and it's just a really great way to get them to draw and to think and to put their ideas on paper in a non-verbal way, because the drawing is emphasized and the words are de-emphasized. So it also gives students that are good artists or good at expressing their thoughts on paper a really great outlet to show what they can do. So highly recommend the video that this is linked to. So here's some examples from class. Obviously a toilet paper dispenser. And when you get the videos, they won't quite be so jerky. But when you cover the light, the toilet paper goes. And when you uncover it, it stops. And then we also emphasize, like we were saying earlier in the webinar, to tweak, test, and not be married to an idea, be willing to change it. It was interesting, too, because one of my engineering students came to me today and about 10 minutes into class and said, well, we were going to do this, but now we've decided that it's just not going to work, and we are starting over with this. And they got it done, and they did a great job. And we were so glad that they realized that their first idea was just not going to work. So here's more dispensers in action. The one on the left, that's Brad's class, and they just taped the whole thing to the chalkboard. And you can see the Skittles pouring out of it.
Yeah, that one was, a unique design of just tape everywhere. And the one on the right here, they got it to work, and then we had just different levels of what did you deem worked? Can he come out great? Could you repeat the process? So again, with that tweaking, so here they just start pushing massive amounts of M&Ms out their dispenser. One of the things I think was really unique about this too was all the different types of designs that they came up with and how they were thinking about it. And as Ellen said, sometimes they start on a process and all of a sudden like, yeah, we had to scrap this, which is not easy for a student to say, I got to start over. So I think that was an important piece. As far as the timing of this activity, we've done it in about 2.5 hours. As far as from start to finish. In my class, I used the AP testing week with my pre-calc students to do this activity. And part of the reason why is each day I don't know who's showing up to class because they all take different AP tests and they're all getting pulled out for part of the day for that testing. So over the course of a week in class, I'll have them do this project with their groups, and sometimes some part of their group won't be there, but the others can work in conjunction for that. So I don't always, have it go for a whole week, but sometimes that's a nice way to do it, and after AP testing for these students to get a little activity and coding in.
Right. So also, we don't just have our kids build either. They never just build. They actually have to document. So they had 3 elements to also submit along with the video of how their dispenser worked. So they had to describe and analyze the process that their team employed to approach the challenge and generate ideas. They had to describe and show the concepts they generated and justify the final design the team selected and how they went through that idea and concept selection process. And then they had to have a dimensional drawing of their final design. And then they had to have a written evaluation or reflecting of the success of the prototype, a test plan that generated benchmarking data. So did you get like 10,000 Skittles and then 1 Skittle, or could you make something that gave an appropriate amount every time? And then they had to submit all that documentation as well, which was really important for the students to do and not just build and have fun with glue and cardboard. I mean, having fun was a really big part of it too, of course.
And just thinking off the top of my head, we have a nice art department in our school with a 3D printer. So I was just thinking off my top of my head after they did these with these primitive supplies. I wonder if they some of them could come up with piggybacking off your idea, Alan, about redoing your design and seeing if you can work with them to come up with some sort of dispenser through the art department type of thing. So again,
yeah, having 3D printers is awesome.
Yeah, so incorporating different pieces of the curriculum. So, all right, what's the smart one? Oh, do we have any questions? Yes.
Yeah, I don't see a question on here. Any questions on the automatic dispenser? Highly recommend this project because, the other thing is this project has all the sensors that are in the kit that TI sells, or TI doesn't sell, but you can get from the TI vendors. It has a light sensor and the motor, both of which are in the kit.
And I believe this one doesn't have a link because there's not one like a.
No, there isn't. There is no link. But if you're interested in more documentation on that, please get in touch with one of us, and we're more than happy to share.
And
there's no link for this. It's not posted yet.
No, and this is the code that you would have to put in there for it. So we could definitely.
And the kids understand this one too because it's so real life. They're everywhere. The automatic dispensers. Every time you go in a bathroom, they're there, and supermarkets and everywhere.
Okay, brings us
to the water. Okay, so the smart irrigation system is a system that waters on demand. So when it's dry and dark, the water should come out and water the plants. So my students were given a marigold, a tomato, and I think a basil plant. I can't remember. And these were 4 of the solutions. Again, they work in teams. And they had all recycled material. They were given the metal foil trays, the plants, the dirt, and the sensors. So there's a humidity sensor, a light sensor, a moisture sensor, and the pump to pump the water. And they had to figure out how to make it so that the plants would get watered at the right time and the right amount. And so they had to do some research on how much water these kinds of plants would need, far apart they were supposed to be spaced, and that sort of thing. So they had to really do quite a bit of research, and then once again document. They had a whole documentation that they had to put that they had to do. So it's definitely a current real world issue because water is so precious. So getting it to the right place at the right time and in the right amount becomes really super important. They had to run tests and collect data. And then the extension was how could they scale it up for a full-size greenhouse? So in our school, we had a greenhouse coming online last year. And so the greenhouse manager came over and that was their customer. And they had to present their idea to the customer at the end of the project. And she was quite impressed with all the different ideas that they came up with. So that picture on the left, they're testing out the pump to see how much it could pump through what length of tubing with the calculator. And the one on the right, I think they're just figuring out how stuff works. Measuring and testing, so benchmarking, which is a really important part, and writing down the results of exactly what happens so they can then tweak it. There's more testing and then planting. So you can see they've got strings going across so that they have the plants measured, and then the tubing. So they had a little trouble. They one of the things they talked about in the benchmarking was how much water. So how big should they drill the holes in the tubing? Fortunately, tubing is not very expensive. So they got done drilling the tubing for the first one, and it just poured out. So it only came out of the first maybe couple holes, and then there was no water left by the time it got down to the end. So they had to redo it. But like I said, tubing wasn't very expensive. It was just their time to drill more holes. So once again, we used recycled material. So it's that's all just containers that you have around the house, or I keep every possible container that I have and just throw it in a box and keep bringing it over to school, and then they can use it. So that's the last slide for the smart.
Slide for the smart water.
Right. So the problems that comes with this particular project is it needs quite a bit of space. So to store the materials and to store the projects themselves, and if the class is used, as most classrooms are, from multiple classes, that's something you need to consider if you're doing any of these projects, is where you're going to put them in between classes. So storage becomes an issue. And then, of course, the materials, some are reusable. We always allow our students to hot glue the motors and the sensors to things, and with the caveat that they've got to be able to take it apart, because if they put a whole bucket load of glue on there, they're going to have a hard time getting it apart. So that's definitely a challenge. So do we have questions on this project or these last couple of projects?
Yeah, I saw a question came in from Ryan. Ryan was wondering what grade level you did the Smart Water project with, or what you recommend.
So I did it with, there were sophomores through seniors, and the seniors didn't do any better job than the sophomores did. So I would definitely, I could see doing this in the middle school, because the coding for this one, I gave them the coding because the emphasis was not on the coding. It was on the engineering design process. So that I would go as low as middle school and right through seniors.
Nice. And then Tom wanted to know how they interface the pump, or is the pump small enough to stay under the current drain of the TI hub? The pump has a, if you look, Brad, can you see with the one of the, has the pump? So it's in the bucket there, and then it's hooked to a set of batteries, which is then hooked to the Innovator. If you can see it in that white bucket on the left-hand side there, the pump itself is maybe 2 inches long, and it interfaces with a battery pack, which then also interfaces with the Innovator. I'm not sure that answered the question.
Oh, right. So I see the question now. So yeah, the batteries, you definitely need batteries on this project. There's several projects if you do need batteries, and one of the big issues is the kids keep forgetting to turn them on. So this uses external batteries, the 4-pack of the AA's, and the automatic dispenser uses just a rechargeable battery like you'd recharge on that you could recharge your phone with, and the mood ring doesn't need a battery. So anything with a motor on it needs a battery.
And then Joshua was wondering if you could provide any insight. For those of you that don't know, the TI-Innovator Hub can be purchased multiple different ways. If you, again, contact any of our vendors, you'll be able to see that. But Joshua wanted to know if you could provide any insight on, say, the breadboard pack versus the I/O module.
So if I was just going to buy, after I got the Innovator and got good with that, I would do the I/O pack next, because those are pretty much plug-and-play sensors for the students, and there's quite a few things you can do with just that. And then go to the breadboard pack, because then you're getting into more detail work and more.
That was like circuitry and stuff like that?
Yeah, circuitry, right. Yeah. Thanks for jumping in on that. So the breadboard pack is, I would say, a little more advanced than just plugging and playing with the sensors.
Yeah, I think there's a little bit more documentation with the sensors as well, as far as some of the activities that you can do.
Right. My kids have done things like mood lamps, and when you put an LED into a ping pong ball. By the way, LEDs and ping pong balls go really well together, and then you can light them up. And so I had a student do a double one where they rigged up a breadboard and 2 LEDs and 2 ping pong balls and made them light up different colors using the random number generator. It was quite cool. And that was a freshman. Can they extend the project to fit the real planting area? Well, yeah, that would be the extension. So what they were required to do when they did this project is present their ideas for how they would ramp it up and be able to water everything in the greenhouse. So running that on the calculator would, of course, not work, but they had to come up with some sort of a power suggestion. So does the breadboard have... So the breadboard's a normal breadboard, and there's on the Innovator, there's a breadboard section which then hooks to another breadboard, or you can just use it as a breadboard. The sensor made the pump activate. So when the conditions were that it was dry, so the moisture meter said it was dry, and the light sensor said it was dark, then the pump turned on, because that's what our greenhouse manager wanted. So any other questions? And of course, Brad and I love to talk about this stuff. So I think you share our information, Mike, at the end, and please feel free to contact either of us as well if you want any more information on any of these projects.
Yeah, thanks so much. I know that I included, whenever everyone downloads the documents for tonight, on your bio slides or your Twitter handles. And I know that might be a good way to get a hold of the two of you and ask questions after the webinar if anyone has them. As we begin to wrap things up, if you do have any last-minute questions for Brad or Ellen, please try to get those asked. I know they'll do their best to get those questions answered.
I didn't go into much about, so we have a question about DC and AC motors. I didn't go a lot into that. If students asked about them, then we had a discussion, and can help. The internet can help there, but that wasn't really part of the lesson, so we didn't really go too much into that.
Thanks. So just a couple things, again, available on our website. I know early on, Brad and Ellen mentioned TI Codes is a great place to get started if you are like me. I was a chemistry major, so I didn't do a lot of coding growing up or in college, but I realize it's important for my students to learn that and be exposed to it. So I've started doing the TI codes, 10 minutes of code with my students on a somewhat frequent basis now, and I'm learning kind of as I go. But it's great having colleagues like Ellen and Brad that I can reach out to if I have questions as things go along. So again, you can learn more about TI codes under the Activities tab on our website. Some people were interested as far as where they could get the TI-Innovator, the TI Rover, the breadboard packs, the I/O modules, things like that. And feel free to search under the Where to Buy on our website, and that will give you a little more information about our educational dealers that we partner with. And then last thing on our website, on any of the web pages, on the bottom right corner of any of our web pages, there's a Contact TI link. And we have with us tonight Robin P. And Robin P., I don't know if anyone saw in my chats, is an educational technology consultant with Texas Instruments. And so Robin's job is really she's a great mediator between things that you're doing and need in the classroom and Texas Instruments as a big company. So if you have questions or wants or needs or need some demonstrations, a great place to start is with your local educational technology consultant. Again, you can find their information by the Contact TI link at the bottom of any of our web pages on our website, and find your area and find your local ETC. I know that they've been really helpful to me as I've been teaching now for 14 years, and I've used my ETC for lots of things. So they're all really receptive, so please feel free to reach out to them at any time. We're excited that this year the T-Cubed International Conference is coming to Baltimore. It's in early March this year. Before we began tonight, Brad and Ellen and I were talking, and Brad and Ellen had mentioned that they're going to be presenting at the conference, and they're actually going to be presenting, I believe you guys said the pet car and the auto dispenser.
Yes. I think so.
Yeah, so I mean, this is a great opportunity that if you kind of saw some things tonight, and you're like, yeah, this is cool. I would like to learn more. Come to Baltimore, come to the International Conference, and you actually will have the chance, Ellen, correct me if I'm wrong, but you'll be building the smart car and the auto dispenser if you were to go to those two sessions.
Right. And Baltimore is not very far away.
From some of you. It's pretty close for Ellen and Brad and I. We're all Northeast Coast people, so Baltimore is pretty close for us. Please feel free to visit our website to learn more information on pricing and more information about the conference in general. We hope to see you there. Right now we have an extra credit contest. More information can be learned by going to TIExtracredit.com. But by doing things that you probably already do, for instance, you could submit your syllabus, you could enter a code from tonight's webinar, things that you typically do on a daily basis or a regular basis as a classroom teacher. You can earn entries, and as you earn more entries, you increase your chance of winning prizes from Texas Instruments. So tonight's code, I'm going to put this in the chat window, but tonight's code for the TI Extra Credit contest is Coding Quest. It's all one word. It's not case sensitive. Again, Coding Quest, and that's in the chat window if you would like it spelled out. When you leave the webinar tonight, a brief survey will automatically appear in your browser. Your feedback guides us as we plan future online events, and we really hope you share your thoughts in the post-webinar follow-up. To receive a certificate of attendance, you're going to click the link in the chat window. There we go. So links are posted for the certificate as well as for the documents that were used tonight. Again, I think Ellen and Brad mentioned this, but in the documents are going to be, there's a PDF of their slides they used tonight, And at the beginning of each of their activities, there's a hyperlink, and that hyperlink will take you either to our website if you're looking for more information about 10 minutes of code, or to the specific activities that they went through. Some of the documents, those activities are pretty large, so we couldn't include them tonight. They were just too big. But feel free to visit that documents link and download them. And if you're watching this on demand, go ahead and copy that link into your favorite browser to receive your certificate. Thanks so much, Ellen and Brad, for everything you shared tonight. We really appreciate it.
That was fun.
And thanks again, everyone, for joining us. We hope to see you back online real soon. Have a great night.
Good night.